These are the transversal notes. So these are page 6 and 7 of your packet. So this is A1 of transversals. And we're just going to start at the top of page 6. Defines what a transversal is. We're going to draw a picture to make that make a little more sense. It's just the line that intersects two or more lines. We're going to start by drawing two lines. They don't have to be perfect, but we draw two lines, and then we're going to draw a line that goes through those two lines, and this right here is your transversal. So that's my transversal. It's the line that goes through two lines. And then here's another example of a transversal down here. So this line Z is the transversal. And then we want to talk about these other two lines. And what I'm going to do is I'm going to take different colored markers, color in the interior, and then color in the exterior. So this is the interior, and this is the exterior. And you'll see these two words a lot over the next couple weeks. We have the interior and the exterior. So angles 2, 6, 3, and 7 are on the interior, and then the exterior are angles 1, 2, 5, 6. Okay, so these are the exterior angles. The interior angles are angles 2, angle 6, angle 3, and angle 7. Okay, and then we want to talk about these words down here. These are going to be the way we identify angle pairs. So each one of these is going to be a pair of angles. These are angle pairs over here. So if we just think about the words, alternate and interior. Anytime you see the word alternate, it means it's on an alternate side of the transversal. If you see the word interior, it means that the angles have to be inside the two lines. So for alternate and interior angles, we are going to have angle, it has to be two of these four angles, because they have to be on the interior. They also have to be on alternate sides of the transversal. So angle 3 and angle 6 go together. That's an angle pair. And then angle 2 and angle 7, because they're on alternate sides of the transversal, but they're both on the interior in between the two lines. Alternate exterior angles, that means we're picking from these four angles, 1, 2, 5, and 6. So if we look at angle 1, we've got to figure out which other angle is on the alternate side of the transversal, but still on the exterior, and it has to be 8. It can't be 5, because that's a linear pair. We have to pick from one group of angles and then look on the other group of angles to pick the other pair. So it has to be 1 and 8, and then 5 has to go with 4. So you cannot match up 1 and 5, you cannot match up 4 and 8. Right, you've got to pick from a separate group. Right, for consecutive interior or same side, you will see this word a lot more. You may see the word same side, but consecutive means same side. So consecutive interior angles just mean the same side of the transversal, but both on the interior. So if you're looking at angle 2, the only other one that's on the interior and on the same side is going to be angle 3. So angle 2 and 3 are consecutive interior angles, and then angle 6 and angle 7 are consecutive interior. Alright, and corresponding angles, you have to look at these. It no longer talks about interior and exterior, so that just doesn't matter anymore for this one. You've got to look at this as a group of angles, these 4. So this angle right here, angle 1, is in the top left-hand corner. So then you have to look at this group down here and figure out which one is in the top left-hand corner, which would be angle 3. So whichever one is in the same spot, top left-hand corner of their group of angles, is going to be corresponding because the spots correspond with each other. So the 2 angles that are in the same position relative to the lines in transversal. So angle 5 would go with, in the top right, would go with angle 7. Angle 2 is in the bottom left, it would go with angle 4. And then angle 6 goes with angle 8. Alright, now we're on page 7. We're going to name these angles. And we're also going to determine if they are congruent or supplementary. So you got 2 choices. Each one is either going to be congruent or supplementary. If you notice, these lines are parallel. It only works when the 2 lines that are not the transversal are parallel. So, for example, we've got only 2 types of angles. We've got obtuse angles, alright, like 1, 6, 3, and then this angle over here that's not labeled. We also have acute angles, like 2, 5, 4, and this angle that's not related. So what I kind of like to do to show y'all is highlight all of these angles. If you don't have colors, you can just make a triangle around one and a circle around another, a box and a circle. But all the green ones are obtuse, and then all the purple ones are acute. So the purple ones are all congruent to each other. So like 2, 5, 4, and this angle right here are congruent to each other. 1, 6, 3, and this angle right here are congruent to each other. But if you match up like 1 and 4, then they are going to be supplementary, right? Because you only have 2 choices when matching these up. It's either congruent or supplementary. So they either are the same or they add to 180. They're either the same or add to 180. You only have 2 choices. So if you look at 1 and 3, they're both in the top left-hand corner, and if you forgot some of these words, it's on page 6. Those are your choices of what you can choose. These are going to be corresponding angles. And then we've got 2 choices. Are they congruent or are they supplementary? They're both obtuse angles. So if you add them up, they're not going to add up to 180, but they will be congruent to each other. So they are congruent. So corresponding angles are always congruent. Super important. Corresponding, always congruent. Angle 3 and angle 6 are on alternate sides of the transversal. and they're also both on the interior. So they're going to be alternate interior angles. And if you look at 3 and 6, they're both obtuse angles, so they are congruent to each other. Okay. Alternate interior angles are always congruent to each other. Alright, 4 and 5, alternate sides of the transversal. They are not on the same side. They're on alternate sides of the transversal. And then are they on the interior or the exterior? They're outside these two parallel lines, so they are on the exterior. And they are both purple. They're both acute angles, so they're going to be congruent to each other. Alright, now we've got 2 and 3. They're both on the interior, so they're going to be interior angles, but they are on the same side of the transversal, so we're going to call them consecutive. Alright, they're on the same side, so they're consecutive interior angles. And then one's purple and one is green, so one is acute and one is obtuse, so they are going to be supplementary, which means they equal 180 degrees. Alright, and this is the symbol for congruent. Make sure we're all familiar with that. Alright, then here we've got 1 and 6. So this angle pair is not an angle pair that we learned today. It's one that we learned last chapter. These are actually vertical angles. And we learned last chapter that vertical angles are always going to be congruent. Alright, we have one more that we didn't talk about last time, but from those words, or on the last page, page 6, but from the words that we talked about, we should know that, so both of them are on the same side, so we call that consecutive, on the same side of the transversal. They're both on the left-hand side. And then they're both outside of these parallel lines, so on the exterior. So they're consecutive exterior angles, which those will always be supplementary. So they will also be supplementary, just like the other one with the word consecutive. There we go. Alright, so consecutive exterior, they're always going to be supplementary. So hopefully you noticed that the only ones that will add up to 180 are going to be the ones with the word consecutive. So these two are supplementary because they have the word consecutive in it. The only other ones that will add up to 180 are like linear pairs. So angle 1 and then angle 5. Alright, this one right here. So we've got some steps. We need to first identify the type of angle pair. So what type of angle pair is this? So we're looking at this angle and this angle. They are both in the top right-hand corner of this group of 4 angles. So they are going to be corresponding angles. Right, and they're both acute angles, and they don't have the word consecutive in it. So they're both going to be corresponding, and they're going to be congruent, because corresponding angles are always congruent. So anytime you have congruent angles, all you have to do to solve for x is put an equal sign in between them. Okay, so we're going to subtract 2x on both sides. add 30, and divide. So x is going to equal 8. Alright, then if it specifically asks for what this angle is, how many degrees this angle is, you would plug in 8 to both of these. So, you know, this is kind of crazy. They each only equal 2 degrees, which it's not drawn to scale, but when we plug in 8, we get 32 minus 30, which is 2, and then 16 minus 14, which is also 2, which is fine. Okay, moving on to the last problem. This is the advanced level. So these usually are angle pairs. You have to set up equations using systems of equations to solve for 2 different variables. So I'm going to real quick talk about the angles that we have. So the green ones are congruent to each other. Purple acute angles are congruent to each other. And then when we match up like a purple with a green, they're not going to be congruent. They're going to add up to 180. But we've got a couple of angle pairs here. So these two are corresponding. So they are going to be congruent to each other. So one of our equations can be x plus 3y equals 5y plus 20, because they're both green and they correspond with each other. And then we've got another angle pair, because these are consecutive interior angles, so they add to 180. They're supplementary. Right. And since these two add to 180, that's how we need to set up our equations. We've got 2x plus 30 plus 5y plus 20 equals 180. I'm going to simplify these equations a little bit just by combining some like terms and putting x on the same side of the equation. But it's the exact same equation. I'm just subtracting 3y on both sides. So x equals 2y plus 20. And then I'm going to combine like terms. So 2x plus 5y plus 50 equals 180. And then I'm going to subtract 50 on both sides. And we're going to end up putting that up here. 2x plus 5y equals 130. Alright. Okay. And then what I also want to do, if you are using elimination to solve this, you want to make sure that the equal sign matches up and it's in the same spot so that your positive and negative symbols are the same. So you'd want to subtract 5y on both sides and basically move it to the other side of the equation. So instead of a positive 5y, you'd want to say it equals negative 5y plus 130. And this way, now you can use elimination or you can use substitution. And I'll go ahead and show you both ways. I'm going to use substitution over here. Substitution. Where I substitute, instead of writing x, I'm going to write 2y plus 20 in that second equation. So 2 times 2y plus 20 is going to be equal to negative 5y plus 130. And then we want to solve for y. So 4y plus 40 equals negative 5y plus 130. If I add 5y on both sides, I'll get 9y. If I subtract 40 on both sides, I'll get 90. So y is going to be 10. And then we want to sub 10 in for y. So x would be equal to 2 times 10 plus 20, which would make x equal to 40. So x is equal to 40, y is equal to 10. If you would prefer to use elimination, I'll show you how to use elimination. I would want to just multiply this top equation by -2, and that means multiplying each one of these, okay? So I'm going to end up bringing it down below and have -2x equals -4y minus 40 minus 40. And when I combine my two equations, this will disappear. And so I've got 0 equals -9y plus 90. And I just need to add 9y on both sides to get 9y equals 90 and y equals 10, which is the same as we got over here. And then you just plug that back in, which we already did. So this is the elimination side of it if you want to use elimination. But substitution or elimination will work for systems of equations.